Hello, this is Professor Kuehn, and welcome back to my lectures on astronomy, where we're discussing the book of Copernicus called On the Revolutions of the Heavenly Spheres, published in 1543. In my last set of lectures, I talked about chapter 11 in the Student's Guide to the Great Physics Texts. In that chapter was included book 1, chapters 1 through 5 of Copernicus's work. For my students, I assigned them to next move on to chapter 13 in a Student's Guide, but this implies that we're going to skip over chapter 12. So it's probably worthwhile spending a couple of minutes talking about what is included in chapter 12 in a Student's Guide. And this focuses on book 1 of Copernicus's Revolutions, chapters 5 through, I believe, 9. So let's spend a few minutes talking about what we will have skipped over. First of all, what Copernicus does is he's going to argue that it is okay to think about the Earth being in motion. Remember, his competitors, so to speak, the ancients and the medievals, believed that the Earth was sitting still. And part of the reason that they believed this was because the Earth is made of earth, as you might imagine. And according to Aristotle's notions, the natural motion of Earth is in a straight line toward the center of the universe. You'll probably recall that Ptolemy argued in his Almagest that the Earth is stationary at the center because that is its natural motion as being comprised of the element Earth. If Copernicus is going to argue that the Earth is in motion around the center, as he's going to do, then he has to somehow reconcile this with the Aristotelian physics that he is implicitly agreeing with, at least to a large extent. How does he go about doing this? In chapter 5, he asks, does the Earth have a circular movement, and what is the place of the Earth? And here's how he argues. He's essentially going to say that the motion of the Earth is governed more by its form than by its element. That's how I'm reading this. He says, circles, or globes in particular, have a natural tendency to rotate. Even my opponents agree with this. After all, that's what they say the celestial spheres are. They're globes, they're spheres, and those have a natural tendency to rotate around the Earth. Well, here's the thing. The Earth itself is a globe. It's a sphere. Therefore, should not the Earth itself tend to rotate if that's the natural motion of a sphere? He's using kind of a syllogism here. Let me draw this out just to make sure you understand. He says circles, so this is the first premise. Premise 1 is that circles or globes tend to rotate. And this was accepted by his opponents, or at least by those who advocate that the celestial spheres rotate. So they would probably concede this first premise. The second premise is that the Earth itself is a globe. And this, too, was accepted by his opponents. So accepted by the geocentrists. And if globes tend to rotate and the Earth is a globe, then the conclusion he arrives at is that Earth, at the very least, also rotates. So this is the form of a syllogism, by the way, for those of you who are interested in the structure of argumentation. It's kind of like, I'll use a modern syllogism, one that's a hot button issue. So one premise would be killing innocent people is wrong. Another premise would be abortion kills innocent people. And the conclusion is that, therefore, abortion must be wrong. So that's another example of a syllogism. And if you're going to attack an argument like that, one must attack the premises in order to, or either attack one or the other premise, or attack the reasoning from the premises to the conclusion. That's the kind of argument style that Copernicus is using here. Now, he goes on in this chapter to remind us that Ptolemy, his essential argument was that the sun appears to move through the sky, and therefore it really does move. Copernicus is going to counter this in this chapter. He says, well, some things that appear to move are not really moving. He says apparent motion can be caused either by the motion of the object that appears to move, or by the motion of the person who's observing the object. So you might think about this, like let's suppose I don't know if this has ever happened to you, it's happened to me, I was taking a train one time, and you're sitting at the train station in the train looking at the platform, and suddenly you begin to see the platform moving backwards ever so slowly. And it's very difficult to discern at the outset whether or not the train is moving or the platform is moving. If you start the train sufficiently slowly, it's difficult to tell what's truly in motion and what's truly at rest. Another example would be, I don't know if this has happened to you, sitting at a stoplight in your automobile, and if the person who's sitting next to you at the stoplight in their automobile suddenly begins to reverse their vehicle, it feels just for a moment like maybe your car is moving forward into the intersection. This happened to me. I slammed on the brakes and then realized I wasn't actually moving. So the point is that sometimes it's difficult to discern what is truly moving and what is truly at rest. This is something that Einstein is going to worry a lot about in the 1900s, but it's already an issue back here at the time of Copernicus. Copernicus is saying, well, just because the sun appears to move through the sky doesn't mean it truly is. Perhaps the sun appears to move through the zodiac, but really it is the Earth moving. And then he goes on at the bottom of page 144 to argue that many others throughout history, particularly coming out of the Pythagorean school, have argued just this. He notes Philolaus, the Pythagorean, this is at the top, I'm skipping over this a little bit, but at the top of page 145, so it would not be very surprising if someone attributed some other movements to the Earth in addition to the daily revolution of the Earth. As a matter of fact, Philolaus the Pythagorean, no ordinary mathematician, a good mathematician, whom Plato's biographers say Plato went to Italy for the sake of seeing, is supposed to have held that the Earth moved in a circle and wandered in some other movements and was one of the planets. So Copernicus is here reminding us that there is historical precedent for believing that the Earth is in fact one of the planets. Let's move on to chapter 6. In this chapter, Copernicus is reminding us that the heavens, that sphere of stars very distant from us, is immense compared to the size of the Earth. How does he argue for this? Well, you'll recognize these arguments straight out of Ptolemy. He says that if you look out at the horizon cuts the celestial sphere in half. That is, half of the zodiac is above the horizon and half below. He talks about if Cancer is beginning to rise on one side of the horizon, then Capricorn is beginning to set on the other. This is at the bottom of page 145. But he goes on to argue that this does not imply, as Ptolemy suggested, that the Earth must be at rest exactly at the center of the celestial sphere. He argues that the Earth could be moving around the center of the celestial sphere. It could be one of the planets, in other words, as long as its orbit is very tiny compared to the size of the celestial sphere. That way, its motion toward and away from stars on one side of the celestial sphere is not discernible. And he also says on page 146 that it would really be very surprising if the entire celestial sphere was spinning about its own axis once every 24 hours, but the Earth was sitting still. Wouldn't it be more sensible for the Earth to be spinning around once every 24 hours than for the celestial sphere to be doing so? Let's move on to chapter 7. This is on page 147. And here, in the next page and a half, what Copernicus is going to do is review the reasons why the ancients, and the medievals for that matter, taught that the Earth was at the center. And the key idea here is that it was based on Aristotle's physics, particularly the notions of heaviness and lightness. So once you accept Aristotle's physics, that earth and water tend to the center and fire and air move away from the center, then it's perfectly sensible that the Earth should be at the center of the celestial sphere. And furthermore, the ancients argued that if they thought about the idea that the Earth was spinning, after all, they read the Pythagoreans or heard about the Pythagoreans as well. The ancients and the medievals said, well, if the Earth is spinning around its own axis or otherwise moving, then it seems like things would fly off of the Earth. After all, what happens when you get on a merry-go-round and you spin around? You tend to flee the center. That's why it's called a centrifugal force. Fuge meaning to flee. It's a Greek word meaning to flee. So centrifugal force is a perceived force that seems to draw you away from the center. If the Earth was in fact spinning, we all should be feeling the centrifugal force. There should be some notable effects on us, and since these are not felt, then it would be absurd to think that the Earth is spinning. So Copernicus is basically reminding us of these ideas in his chapter 7. Now, on chapter 8, what does he do? He says, well, the aforesaid reasons, the reasons given in the previous chapter, are not adequate. There are better explanations. How is he going to address the specific issue of the natural motion of the Earth? He says perhaps that the Earth itself has a natural circular motion. This is what he hinted at about 2 pages ago when he said because the Earth is a globe or a sphere, perhaps that is its natural motion. And perhaps the heavens themselves, that sphere of fixed stars that people have talked about for centuries, perhaps that is the thing that is truly stationary. Because he says if it spun around, if this enormous celestial sphere had to spin around once per day in order to give rise to the rising and setting of all the stars, then it should too feel this centrifugal force, this force that's pulling things apart, like what his opponents were saying should happen to people on Earth if the Earth was spinning. And if it is feeling this centrifugal force as it's spinning around, then it should be expanding in size. This is what he's talking about on the second paragraph in his chapter 8. He says, for the farther the movement is borne upward by this force, the faster will it be on account of the ever-increasing circumference, which must be traversed every 24 hours. And so the sky would increase with the increase in movement, and so on. It would keep spinning and expanding, and eventually it would become infinite in size. And now what he does is he uses another one of Aristotle's arguments against Aristotle. He says, in Aristotle's physics, Aristotle claims that that which is infinite cannot be moved in any way. Things that are infinite in size can't be moved. That's one of Aristotle's axioms. And he says if this celestial sphere was spinning around so rapidly, once every 24 hours, it would be expanding, become infinite in size, and then it would contradict this axiom of Aristotle's, this other axiom, which says that the infinite size thing cannot move. So he seems to think that this is a good argument against the spinning of the celestial sphere. And furthermore, he says, well, what if, is there any way that the Aristotelian could argue against this infinite expansion of the world or of the universe? Well, perhaps there's something outside of it that's holding it together. This is what he's talking about in the third paragraph. Perhaps there's something from the outside that is containing it. And he says, well, that doesn't really make any sense. Why not? Well, because the universe is everything that exists. So there's nothing outside of the universe. And nothing cannot act to hold something together. That would be absurd, he says. And so finally, in the last paragraph, he goes on to say, let's leave to the philosophers the debate as to whether the universe is infinite or finite in size. Let's stick to the knowledge that the Earth itself is a finite-sized spherical globe. And he says, perhaps its motion follows from its form. Its natural motion follows the form that it has. That is, it's a globe, it's round, and round things tend to rotate. On page 148 on the bottom, he says, perhaps the appearance of the motion, he's going back to a point he brought up earlier, the appearance of the motion of the heavens is really due to the motion of the Earth. If I read, he says, why not admit that the appearance of daily revolution belongs to the heavens, but the reality belongs to the Earth? And then he quotes Virgil's Aeneid, where he says, we sail out of the harbor, and the land and the cities move away. So there he's talking again about the idea that it's hard to tell what's truly at rest or what is truly in motion. Well, one of the other arguments that the ancients had is if the Earth was spinning, there should be some kind of wild wind as the Earth spins underneath the air, the atmosphere. And birds should feel this gale force wind. But how does Copernicus address this? He says that if the Earth has a natural circular motion, if it's spinning around its own axis, then the oceans and the air above it would participate in this motion. They would be dragged along with it, so to speak. And then you would not really feel any gale force winds as you're standing on the surface of the Earth because the atmosphere is rotating along with the Earth. And he goes on to say that his opponents even argue in a similar kind of way. After all, they argued that the celestial spheres were rotating around the Earth, and as these celestial spheres rotated around the Earth, they dragged the top layer of the Earth's atmosphere around with them. That's, by the way, how they account for the existence of meteors and comets. They see these as atmospheric phenomena, as the celestial spheres rub against the Earth's atmosphere, causing motion and heat, which generates meteors. That, by the way, is why the study of weather is historically called meteorology, because the ancients believed that meteors were an atmospheric phenomenon, not something that happened out in outer space. Copernicus, by the end of chapter 8, goes on to say, "You see therefore that for all these reasons it is more probable that the Earth moves than that it is at rest, especially in the case of daily revolution, as it is the Earth's very own. And I think that is enough as regards the first part of this question." So up until this point, he's been attacking and criticizing the Aristotelian, Ptolemaic, and medieval view, trying to punch holes in it and say that it would be more plausible to have the Earth spinning. And then finally in chapter 9, he asks whether many movements can be attributed to the Earth and concerning the center of the world. So is the Earth not only spinning, but is it also not moving around the sun? And this is what he's going to argue. And I'm just going to read parts of this to you and comment on it as I go. He says, "Therefore, since nothing hinders the mobility of the Earth, I think we should now see whether more than one movement belongs to it, so that it can be regarded as one of the wandering stars. For the apparent irregular movement of the planets and their variable distances from the Earth, which cannot be understood as occurring in circles homocentric with the Earth, make it clear that the Earth is not the center of their circular movements. Therefore, since there are many centers, many planets, it is not foolhardy to doubt whether the center of gravity of the Earth, rather than some other, is the center of the world. I myself think that gravity or heaviness is nothing except a certain natural appetency implanted in the parts by the divine providence of the universal artisan, in order that they should unite with one another in their oneness and wholeness and come together in the form of a globe." Now he's saying two very interesting and important things here. First of all, he's reminding us that it's a live possibility whether the Earth is in motion around the sun like one of the planets. And then he goes on to speculate about what we have been calling gravity up until this point. Remember, this is long before Newton's theory of universal gravitation, where all masses attract all other masses. But the word gravity had been being used for quite some time, but it was meant to be a terrestrial heaviness, or a heaviness that things feel toward the Earth. What he's suggesting here is that gravity is a natural appetite, or a natural tendency that things have to cluster together into spherical shapes. This natural tendency, or appetite, you might say, was implanted in every object by the divine artificer, by God himself. And that, he says, is what might be responsible for the Earth's circular shape, and for that matter, for the sun's circular shape, and the moon's circular shape, and the other planets' circular shape. Copernicus would not say that the sun is attracting the moon, or the Earth is attracting the moon, or the sun is attracting the Earth. Rather, the parts of the sun have a tendency to coalesce together, forming the sun. The parts of the Earth have a tendency to coalesce together, forming the Earth, and the parts of the moon have a tendency to coalesce together, forming the moon. This is somewhat speculative, but you'll see here the seeds of a more broad theory of gravity that are being planted by Copernicus.